Hello, here's the video about horizontal asymptotes. And horizontal asymptotes are the in behavior. In other words, we're saying what is this rational function r of x like? Remember, p of x and q of x are polynomials. What is it like for large x? So we're looking at the long-term behavior of a graph. So we're seeing what's happening on one of the ends. And it's kind of there's a really simple rule for figuring out what's going to happen. And again, I was hoping that what we did in class would help you figure this out, but it didn't. So I'm just going to state what the three rules are. Now remember, r of x equals p of x over q of x, and these are polynomials, so they have a degree. And here's the rule. If the degree of p of x is equal to q of x, you have a horizontal asymptote. Y equal a, and I'll tell you how to find out what that is, but it's not going to be equal to 0. Okay, so that's the first thing. The second example is going to be the degree of p of x is greater than q of x. So the degree on the top is higher than the degree on the bottom, and here there's no horizontal asymptote. And the graphs go, the in behavior is either going to be plus infinity or minus infinity. Again, I'll go over that and how you can tell. And the last one is where the degree is bigger on the bottom, so the degree of the top is less than the degree of a polynomial on the bottom. And so here, so that's the bottom. And so here, the horizontal asymptote is y equals 0. And the nice thing about all this is this always happens. And what I'm going to do is go through 3 examples, and hopefully you'll understand this, and then I'll come back and recap it. Okay, so again, I'm going to share the screen, and we're going to look at examples at Desmos, and I want to go to the first example here. Okay, oops, first example. So let me find my examples here. Shoot. So let me get rid of that. Sorry for that little glitch. Come on, there you go. Good. Okay. Sorry about that. So the degree, we have a horizontal asymptote. It's all about the exponents. And so here, this example, the degrees are the same. But first, a recap. Here's the function we're going to look at. But I just want to go over really quickly the vertical asymptote. We see that that r of x, the bottom function, is 0 at x equal 2. So I graph the horizontal asymptote. And that's all we need to know here. We have a horizontal asymptote at x equal 2. And you can see it here. And I'll zoom in a little bit. And you can see how the graph eventually approaches x equal 2. That's what we did before. Enough said. Now for the horizontal asymptote, so let me turn that off. For the horizontal asymptote, I see the degree of the top function is 1. And the degree of the bottom function is 1. And there's going to be a horizontal asymptote at y equal 3. So how do I know that? First, let me show you why I say that. There's y equal 3. And I'm going to zoom out so you can start to see what happens. See how the graph eventually overlays the graph of y equal 3. Okay, and if we zoom in, you can see that the graph of the function r is a little bit bigger than y equal 3, a little bit smaller here, but as we keep going, the graph, the top part of the graph, the positive part of the graph gets closer and closer from above to y equal 3, and if we look on the left side, again, you'll see the same kind of thing, that the graph, which is in orange, eventually approaches the y equal 3 asymptote. Okay, so let me go back to here, and why? Now, here's what I didn't say earlier, but you look at what's going on. I'm going to look at this function again. And for a really, really, really large x, that 2 here is really insignificant. and the -2 in the bottom is really insignificant. So imagine if you had $1 billion and you lost $2, you wouldn't notice it. Or if you gained $2, you wouldn't notice it. So again, R of x, the top is really going to be 3x, 3x plus 2 is going to be pretty much just 3x, because that 2 doesn't matter. And the bottom is going to act like x. So x minus 2 is really like x. So really what the function acts like is 3x over x, which is 3. And that's what you're seeing when you graph the vertical asymptote. Vertical asymptote is 3. And again, I just want to give you an example. I plug in some large numbers into x. I plugged in 1,000,000, and it was just a little bit over 3. I plugged in negative 1,000,000, a little bit under 3. Let's see if we can see that here. I'm going to really, really zoom out. Here we go. Good. Okay. Again, if you look here, you can see that the graph y equal 3 is pretty much the same as the graph of, which is an orange, of r of x. Okay. I don't know how helpful it was to do that. But anyway, okay. So next example. We have the degrees of the top is bigger than the degree on the bottom. From what I said earlier, what's going to happen is there's not going to be a horizontal asymptote. But again, since we've been talking about vertical asymptotes, this is a great chance to review. I look at r of x. It's going to be equal, the bottom is equal to 0 at x equal -2. There's going to, and I plug it, there's a horizontal asymptote there. I mean a vertical asymptote at x equal -2. Okay, like we did in the last one. Okay, enough said. Now remember, the degree of the top function is 2, the degree of the bottom function is 1. Therefore, according to what I said earlier, this graph isn't going to have any horizontal asymptotes. It's going to go off to infinity or minus infinity. So I'm going to zoom out, and I think you'll see that. See how the graph just keeps going up on one side and down on the other side. Okay, now what's going on? Well, it's the same idea. For large numbers, 2x squared minus 1 is really just about 2x squared. And for the bottom, x plus 2 is really just going to be about x. So r of x is going to be more or less, for large numbers, 2x squared over x, which is 2x. And just to accentuate that, here, let's go back here. I want to zoom in a little bit so we can see the graph. We got the vertical asymptote. Now I'm going to put in the function 2x. And again, it doesn't look very close, but look what happens as I zoom out. The graph gets closer and closer to 2x. So really, what we're saying here is that this function for large x is indistinguishable from 2x. And I think that's important to see. So that's no horizontal, there is not, in fact, let me make that clear. There are no horizontal asymptotes since the degree of the top is bigger than the degree of the bottom. But again, I want to return to the fact that this function for large x is indistinguishable from this function. And so are virtually indistinguishable. So I plugged in 10,000, and you see that for the given function, it's a little bit under 20,000, but f is exactly 20,000. When I go up to 100,000, you see the same thing, that the graphs are very, very close. They're just 4 off. And I'm going to just plug in a big number here. 3, 1, 2, 3, that's a billion, a trillion. Now, because of rounding, you're not going to see any difference. That's because this function, the graph is rounding. So you're really not going to see a difference. And that's what I mean. This function and the given function r are virtually the same function for large x. Okay, if we plugged in a negative number, you'd get the same things. I might as well do 1. Million, billion, trillion. And you can see we're getting the same answer. Okay, so the last example, this example is going to be where the degree of the bottom is greater than the degree of the top. And I said when that happens, the horizontal asymptote is always y equals 0. So let me accentuate that right there. Now, I was going to go through the review again, but the bottom, x squared plus 1, is never 0. This is always going to be greater than 0, since x squared is always 0 or bigger. So there's no vertical asymptote. We don't have to worry about it. Okay. Now, since the degree of the top is 1 and the degree of the bottom is 2, as we said before, there's a horizontal asymptote at y equals 0. Well, why? Well, let's go through this same thing again. The top is really 3x for large x. The bottom is really indistinguishable from x squared. And so overall, we get 3x over x squared. That's 3 over x. That's what I'm saying right here. And really, for large numbers, 3 over x is almost 0. Okay, so again, I'm going to add the horizontal asymptote. Again, you can see it here. It doesn't look close, but let's zoom out. And you can see the graph is approaching y equals 0 from the top on the right and from the bottom. And again, if we zoom out some more, and the horizontal asymptote and the graph are pretty much indistinguishable. And the last thing I want to do is remember I said this is really acting like the function 3 over x for large x. Well, here's the function 3 over x for large x. Let me turn off the horizontal asymptote. And again, if we plug in, they don't look very similar there, but then as you see, what happens is they start to get very close very quickly. So except for that little blip, the function r of x is very, very close to 3 of x. And again, I'm just giving you some examples here. I'll plug in another number, like I'll plug in a trillion again. Let's see what happens. And again, here you can't really see, so let's drag this out. Again, they're indistinguishable. Because of the rounding that the computer does, it doesn't see any difference between 3 over x and r of x. Okay, so that's basically it. I'm going to go review things again, and that'll be it for the video. Hopefully this was helpful. So I'm going to stop the share. And again, just to review, and if you got it, feel free to leave. We're looking at r of x, and it's p of x over q of x. These are polynomials, and they have a degree. So if the degree of p of x equals q of x, you have a horizontal asymptote y equal a not equal to 0. Okay, we saw why that is. If the degree of the top is bigger than the degree of the bottom, no horizontal asymptote. And the graph goes to infinity or minus infinity at the ends. Goes to either one. That's what the end behavior is. And finally, if the degree of the bottom is the big one, so the degree of the top is smaller than the degree of the bottom, then you have a horizontal asymptote at y equals 0, always. Okay, that's it. So just a quick review, horizontal asymptotes, that's when we look to see what's happening on the extreme ends of the function, what's the long-term behavior. A vertical asymptote happens where we have some finite number where there's division by 0 and the graph really shoots up. So I hope this helps. Okay. So I will see you in class on Thursday. Thank you.